ahead and start. It's all about logarithms today. Logarithms and exponential functions are inverses of each other. We talked a little bit about inverses earlier. What is the relationship between a function and its inverse? See if y'all remember that. What now? Not quite. You're on, well, something is opposite, but it's not the slope. That would be perpendicular. You got the negative reciprocal slope. You switch your y's and x's, right? And when functions are inverses of each other, what winds up happening is that they reflect about the line y equals x. Now, the logarithmic function, or the exponential function we looked at last time, takes along this shape right here. And we'll call this e to the x, e's being the natural base. I mean, we could have called it 2 to the x, we could have called it 5 to the x, whatever. They all take along, as long as that base is greater than 1, they take that general shape. The inverse of the natural log is, the inverse of e to the x is the natural log of x. The natural log of x takes, well, it doesn't quite. A little bit more like that. And you have that button on your calculator that says ln. That's just standing for the natural log. So the natural log of x takes on that shape there. So you have y equals e to the x and y equals the natural log of x. And that's what we're looking at here. They are inverses of each other, so I'm not going to go through the switching around of them right now. Possibly at the end of class I'll show it to you, but we don't know enough right now to go through that. Now, a logarithm is an exponent. It took me forever to understand logarithms, and it wasn't actually, I just memorized my way through it when I was a student. And my first year teaching, I was teaching at the alternative school, and I had a student come to me, and the first day he came to me, he was doing logarithms, and I just remembered the rules, and I showed him the rules I had memorized, but it didn't really make sense to me. Next year I was teaching at the alternative school, same thing happened. A kid got sent to me. It's kind of like this was around prom time, and he had a couple of students who didn't know how to act at prom or whatever and got sent to me. Anyway, that student came to me, and I got to thinking, if I'm going to be teaching this, which it looks like as long as I'm going to be at the alternative school, we're going to have seniors who don't act right at prom, and we're going to be doing logarithms. I need to understand what it is. And the very first sentence of one of the books I read summed it up for me. It said a logarithm is an exponent. I don't know why. I had a great teacher in high school. I know she told it to us, but for some reason it didn't register with me. It wasn't until then that it registered with me. Hey, a logarithm is an exponent. So once you get that, the rules that we're going to talk about with logarithms are going to make more sense. But the first thing we need to understand is that if you have the log, and this is any log, this is not necessarily the natural log, this is the log of any base, and you read that as the log base b of n. It's not the log of b to the nth power, it's the log base b of n. And if the log base b of n is equal to m, that implies exponentially that b raised to the m power is n. Think about it. M is the logarithm. It says the logarithm is m. So if m is the logarithm and a logarithm is an exponent, then it needs to be written as the base to the exponent equals to that n value. Is there a question about that? All right, now let's look at an example of this. Let's say that we have 4 raised to the second power is 16. And we want to write that in terms of logarithms. Well, what's the base here? 4. So we rewrite it as the log of the base of 4 And what is the exponent? 2. So it's equal to 2, which leads this to be 16. So the log base 4 of 16 is 2. The exponent associated with 4 to give me 16 as the answer is 2. Is there a question about that? Now, it may just be a situation where they ask you to solve. Well, let's do one the other way. Okay, let's say I start off with the log base 2 of -3 is 1/8. Okay? So this starts out in logarithmic form, and I want to turn this into exponential form. Well, the base is 2. The exponent is -3. So 2 raised to the -3rd power is 1/8. Is everybody okay with that? All right. So sometimes you're just going to be asked to solve stuff. You might have the log base 9 of x is 1/2. Now that's not as hard as it looks, especially when we break it down and write it out exponentially. It implies that 9 raised to the 1/2 power is x. Is there a question about that? Okay. Now, what does 1/2 as an exponent mean? No, that's half. That'd be 9 times 1/2. But what does 1/2 as an exponent mean? Square root, yeah. So this is really saying what is the square root of 9, and it's 3. Now, a couple of other things here, real quick. More about the properties. B is going to be greater than 0, and B cannot equal 1. Now, why didn't I just go ahead and say B had to be greater than 1? Why can't I just say B has to be greater than 1? Why did I have to say B is greater than 0, but B can't be equal to 1? Yeah, you've got fractions in between, so we can have fractions right here. But we just can't have 0 or anything negative, and we can't have 1. Why do you think we can't have 1 there?
It wouldn't have the same curve.
Not quite. Mathematically, not graphically. Mathematically, why do you think we couldn't have 1 there? You're right. If you graphed 1 to an exponent, it wouldn't be that. What would 1 to an exponent be if we graphed it? It'd be a horizontal line, right? At 1. So that may help you with this answer here. You'd have an infinite number of solutions, because the log base 1 of anything would give you 1. I mean, yeah. So that's what's happening there. Are we okay here? All right. N must be positive. Now again, why is that? Why would N have to be positive? Well, I'll answer that question for you. N has to be positive because if this is a positive number here, a positive value to any exponent is going to have to be positive. Remember, a positive to a negative exponent, that just means we turn it into a fraction. But what did we see here? It was a positive fraction, right? And M can be anything, any real number.
So these rules apply to any logarithm?
Yes. These rules apply to any logarithm, whether it's the natural log or. Now, look here, just so you know this, the natural log of x, you don't see people write it like this, but it is the same thing as the log base e of x. Okay, now, because logarithms and exponentials have an inverse relationship, with the same base, b raised to the log base b of x will equal x. And the log base b of b to the x will also equal x. That just has to do with their inverse relationship. You'll use that property in equations. You'll get to some problems that are logarithmic equations, and you're going to be wanting to solve for the exponent, and that inverse property is going to allow you to be able to solve these problems out. So if I have the log base 6 of 6 to the 7th power, that's just the same thing as 7. Because think about it. If you think about it in terms of these properties over here, that's like saying, what does 6 to the 7th power equal? Well, 6 to the 7th power equals 6 to the 7th power. So when you go home tonight and your siblings are asking you about what you learned in that college class you're taking, you say, hey, we learned that 6 to the 7th power is equal to 6 to the 7th power. Pretty profound, Kate. 1/2 to the log base 1/2 of 1/8 is 1/8. Again, this is big time.
Can you explain the 1/2 log, 1/2 and 8 equals 1/8?
I can't yet. I'm just, all I can tell you at this moment is to trust me.
Is the first 1/2, is that supposed to be in front of the
Give me
log?
1 second. All right, it's still recording. Okay. All right, ask your question again.
The first 1/2, is that like supposed to be below log, or is it in
Yeah,
front
this
of
is the
log?
base, and this is the base, and that is the exponent. So basically, the 1/2 is where the b was here in this log base, 1/2 of 1/8.
What is, in the top where you have written out, what is the word before log? Because?
Yeah, because logs. Thank you. Because Because logs and exponentials have inverse relationships when the base is alike. Now, if I said, if this had been 4 to the log base 1/2 of 8, 1/8, we would have to do something different with that. We'd have to think about how we could write 4 as 1/2 or 1/2 as 4. That's not gonna happen in this class. But it still needed to be said. Your calculator has something that's just the log button. If you just see the log of x, that is the same thing as saying the log base 10 of x. 10 being the understood base. Our number system, our numeric system is the base 10 number system. So if we have the log base 10 of 1,000, and we want to solve that out. Well, what do you raise 10 to get 1,000 as the solution? Well, what's 10 times 10? And what's 100 times 10? 1,000. So what did we raise 10 to get 1,000 as our solution? Be careful, not 100. 3.
Oh,
Does that make sense?
yeah.
Okay. If we multiply it times 100, we get 1,000. But exponentially, it's that. So the log base 10 of 1,000 is 3. So if you have one of these calculators with you, just find the log key and do the log of 1,000,000. It's 6, yeah. You didn't even need your calculator, did you?
There's 6 zeros.
There's 6 zeros, so it's 10 to the 6. Good.
So, let's see. The base is understood as 10.
If it's not written, it's understood to be 10. If that's a great. It's called the common logarithm. If the base is not written, it's understood to have a base of 10. And if it's natural log, it's understood to have a base of e.
Is it E?
Yeah.
Any number above 1?
No, e is approximately 2.72. It's an irrational number. Okay, so again, just the regular log, common log of x. And we want to graph this. Well, think about what we said, that this number can never be. All right, it can actually. The base can't be 1. It can't be negative. So what winds up happening is this graph takes on this shape right here. Again, we looked at that a little bit earlier. And we would say that the domain of this graph is from 0 to infinity. What do you think the range would be? Yeah, it's all real numbers. This will eventually, very slowly, but it will eventually cover any y value that we come up with. Give me a second.